Okay, hello. I want to talk about the new version of Cerebral and some other stuff going on. And I haven't really prepared this, so I'm basically going to wing it. But hopefully it will make sense and we can make a good decision together on how to move on with the project. Uh, so I've been actually working pretty hard on this next major feature, and then there has been other people as well who has affected this release with previous work and has helped out with the current, like lately worked on the new major release. And the new stuff for 5.0 is that there's like a general watch concept inside Cerebral, which is subscription based. Unlike how state is managed now, like now all the components registers to this dependency store, and then whenever there's a state change, like the changes are checked against this dependency store, and the dependency store is actually updating. So it's kind of like a push thing, while this watch concept is a subscription, which is more like a pull thing. But it allows for, like we can in this version say state and let's see, oh, this looks a little bit weird, module like this, yeah, that's good. State, and then we are actually able to say foo bar, and then we can say upper foo, and then how did this work? We can, oh sorry, get, we can say get module state, for example, module state.foo to uppercase. So we can put state into the tree itself, and then we can inside components. So when we connect something and we have a component, we have this thing. Well, this should typically be a class actually. So let's see here, some component extends react.component, and then for example on component did mount, we can say this.props.reaction, then we can watch some state like foo state.foo, and then we can handle this and do something. And we can actually even inside module we can say what did we call it? Reactions, of course. Reactions, and then you can on to-dos change we can have a reaction that looks at the to-dos, for example. Let's use module state here as well. To-dos, and whenever that happens, it can, for example, synchronize the to-dos to local storage, for example. So this watch concept is used for different things, but it's actually quite complex, and we're going to look into that. Okay, but this is like generally what we can do. It just extends the functionality, and then it's the debugger. I'm not going to go through that because I have some videos on it already. Basically, we get a ton more information about what's happening inside the application. We see what is being watched at any given time, like what state is watched, what computeds are watched. We get like a list of every time there's some state updates, we know what is affected by those state updates, like what computed, what components. It's super awesome. And in addition to that, inside the state tree, these computed things from the state tree, they are actually, you can see them in the debugger, and they are actually updated as well. So that's really awesome. And then there's this consistency thing, where everything from what is now called the app, this was previously the controller, as get inside my action. You have get, and inside the computed you have get, as you saw up here, get, and even inside the reaction you have get. Everywhere you have this get thing, and what get does is, let's see, what get does is basically allow you to use these proxy things to extract state. So that's all good. So it's definitely an improvement of the current API, though Cerebral has actually become quite more complex because of these feature changes or feature additions. So I've been working on this other thing where I've been exploring this concept of proxies even further, because I've been doing this for quite some time, like playing around with proxies and what can they be used for and how to use them and all this stuff. And suddenly it just hit me how this could actually be used. So I've been playing around with the project, and it was like really successful. It's like tiny library that basically exposes a single state tree and tracks mutations on that tree, and it tracks when you access stuff in the tree totally automatically, which is really awesome. And the data you get with this tracking is actually compatible with the data we pass to the current debugger, which is also really awesome. And then we see that, okay, MobX5 is released, which is based on proxies. We see Vue.js gets a new version that supports proxies. And the only reason to not support proxies is IE 11, because it doesn't support proxies. And at some time, we have to drop IE 11. The question is just when do we drop it? And for how long should IE 11 prevent Cerebral to become the project it wants to be? Sorry. And I come to this point now where this is getting like very annoying. Because the current version of Cerebral works really well. You can build super complex applications with it. You get a ton of information from the debugger. And we can release the new major version of Cerebral now, but it doesn't make Cerebral the project I personally want it to be. It just adds more cool features, but it makes the code base a lot more complex. But if we drop IE 11, we can do tons of cool stuff. So I'm going to try to show you this by first looking at how complex the code is now. Because this whole new computed reaction stuff is based on something called a watcher. And a watcher looks something like this, where you kind of like, you can subscribe and we can use the same dependency store as a component, but it has this subscription model thingy. And then on top of that we have the view, which is for components, and this handles a ton of stuff related to props and composing props with state and composed into state access, and there's just so much logic to handle all this composition stuff. And then we have reaction on top of that. And then we have compute on top of that again. So it's just a ton of code. You have to excuse me, I think I'm getting sick. But okay, as you can see, there's so much code related to all this functionality. But if we use this new proxy approach, we can make things a lot simpler. First of all, inside actions, we can just say state, for example. and you can do state foo equals bar, and you just treat it. You just mutate it as normal, but all this is protected. Like, you still can't mutate outside the actions. Everything's tracked perfectly by the debugger, and it just works. So we don't need to have like the current new version of Cerebral would have like a store and get. So if you did sorry, store and get, so you would say store set state foo bar, and if you wanted to get some state, foo get state foo. Here you just say state foo equals bar and state foo. Like, you just use it as normal. That's really awesome. Let's see. And then it's the components. So when MobX came out, there was one argument that it was too implicit. Now, there's a reason why MobX is implicit. It's because it automatically tracks state access for you. So unlike Cerebral, where you do this kind of thing, state.foo, with a MobX approach, you would do something like this. Oops. And then you would get the state there, and you would just say state.foo. And the thing is that MobX automatically understands that you're accessing foo. And this is implicit. Like, here we are explicit about what state we want. Here it is implicit. The connect just tracks whatever state you access, and we will re-render. But the point is that it's not about being implicit and explicit. There's a much more important reason why this is a better idea, and that is because, and I'm going to use an example from Code Sandbox here. So in Code Sandbox, you have a sandbox, and inside the sandbox you have modules. And one module has some code. Now the point is, in Cerebral, when you depend on the sandbox or the modules or a single module, it will re-render when the code is changed. So that means all the parts of all the components depending directly on the sandbox or the modules or a single module will re-render when there is a code change. And this is the same with Redux. And there's no way to handle that effectively, either with Redux or Cerebral with its current version. The only way to handle that the right way is to use the MobX approach. Because inside MobX, if you were to grab sandbox here, that's the only thing you grab from the state. Let me drop MobX, let me talk about proxy state tree, how it works there. This component will only re-render if the sandbox itself was changed. So if the sandbox value itself changed, then this component would re-render. But you would probably access something more. For example, you would do modules, maybe you would map over it. And inside the module, maybe you use the module name. Now, this component would re-render if we change out the sandbox value, if we change out the modules value, or if any of the modules inside the modules array was replaced, it would re-render, and it would re-render if any of the names of the modules were changed. But it would not re-render if we changed one of the other module properties, because we haven't accessed it. And that's the secret. Like, this is why this is such a great approach. It does exactly the right thing in terms of rendering based on what you actually access. So it's actually super awesome. Okay, I think that's it. Action, connect. Yeah, but the point is, like with sequences and stuff, by sequence, we still have the same stuff. Like we can say set state.foo equals bar. That's perfectly okay. But it will be contained here. The only place we use this kind of proxying of state is with sequences, which I think is nice to isolate it there instead of exposing it everywhere. Another benefit is that if you were to use TypeScript with the full chaining API, let's see, action, it makes it easier to express state foo equals bar. It's just less effort to write your actions in line like this. Cool. So basically, where I really want to go with Cerebral is to make Cerebral not even about the state. It can use this proxy state tree concept with function tree. That is like the scope of Cerebral. And then we have these computed concepts, reactions, and all this goodness, which kind of like helps you manage state when you build applications. So I wanted to show you an example of how this proxy state tree thing works, because I made proof of concept implementation. Now you remember this whole file with the view and stuff? Like, where was it? Yeah, here. This whole crazy thing here. That is needed, plus reaction is needed, plus if we go into Cerebral and, for example, React here, this thing is needed, HOC, and then the container is needed. So that's kind of like all the code that's needed. And this is all the code that is needed when I now made a proof of concept with the view. So as you can see here, it's no biggie. I can click this thing and it just updates the bar down there. And it's like a silly library implementation. And what it does is when we use it, we just initialize it with some state. And then inside the view component, we connect it and we get access to this store. It's just automatically connected. So when you have a method, you can point to the store and make changes to it. And as you see inside the template, I'm pointing to the store. Now, the point here is that the only thing I need to implement was to initialize a proxy tree with the state. And then I create a connect thing. So only thing this does is to wrap the methods of the component, and it wraps it by using the proxy state tree to start the mutation tracking. Because in this silly library implementation, it needs to track the mutations and first of all open up for doing mutations and then track what mutations are done when you call the methods. Like this will be done with the Cerebral actions. So it just starts the mutation tracking and it stops it. That's all it needs to do. And then before the component mounts, the proxy state tree starts paths tracking. And this is accessing paths inside the state tree. And then it just attaches the current, like the state itself from the proxy state tree on the store here. And then when it's mounted, it stops tracking because now it has run through the code and the state has been accessed. So it stops the paths tracking, which returns the paths that has been accessed. And then these paths are added as a mutation listener to the state tree. And then you give it a callback. What should happen when these paths are affected by a mutation? And in this case, it's to just render the component. And then we keep a reference to the listener. And then when the component updates, it does the path tracking again. It's done updating, it takes the paths, and it updates the listener. And this has to do with the template might have some if or switch statements or whatever. So the same state might not be accessed every time. So we need to update the actual paths accessed in the component. And then when the component is destroyed, it disposes the listener. And that was all that was needed to make this work. And this is actually like a valid approach to state management in Vue. Like you could use this now and you would have like an external state store that you could access at every connected component, and you can change that store from the methods of any component. Might not be the best way to manage state, but at least it handles it automatically for you, all this rendering stuff and everything. So that says something about how simple this project is. And then I have this implementation of computed. And the only thing I needed to do here to make this work is that inside proxy state tree, it will, whenever there's a function on a property, it will call that function and give the instance of the proxy state tree so that you can do stuff. So I spent a ton of time implementing the new subscription-based computed system for the next major version of Cerebral. And this implementation took me 20 minutes. So what this does is it takes a callback, as you can see it's being used here, where it gets the state and it accesses the state and does something. So the computed gets the callback. It has a flag if it's dirty or not. It has a reference to the proxy state tree listener. It has a value, it has some paths, it stores the reference to the callback, and then it doesn't return this instance of the class, but it returns a function. And this is the function that receives the proxy state tree. So what happens here when the computed is dirty, and it is by default, is that again it just does the same thing. It points to proxy state tree, starts the path tracking, it calls the callback with the state value, and whatever's returned is the current value. And then it says that it's not dirty anymore. We stop the path tracking. And if we already have a proxy state tree listener, we just update it with the paths. If we don't have that listener yet, we have to create it, give it a path, and then tell it what should you do whenever these paths are affected by a mutation. And that is to set this computed to dirty. It doesn't recalculate the value, it just put it into dirty mode, which means that the next time this computed is accessed, then it will re-evaluate the value. So as we can see here that I fire up the tree, I have my computed, I go and grab the state out of the tree, I go and I access the upper foo property 2 times, and then it says it's dirty, it evaluates, creates bar, but the next time I call it, it's not dirty, but it still returns the same result. Then I start the mutation tracking. This is just to test it. I change the state, and I stop the mutation tracking, and now I access the property again, or the state property, and now it's true, and bar 2. Okay, so this was a lot of technical details, but my point here is that I personally think that we should do this. And the reason I really like this is that we can actually implement Cerebral with TypeScript. It doesn't make sense to actually implement this in the current Cerebral. It actually makes sense to rename the Cerebral folder into Cerebral old, and then create a new Cerebral folder and actually implement Cerebral in TypeScript, and then move over logic like the dev tools, for example, because we don't really need much from those Cerebral. We don't need a model. We don't need reaction. We don't need view. We don't need watch. There's so many things we don't really need. Yeah, okay. So, yeah, and like Cerebral will move in this direction no matter. That's for sure. The question is, should it do it now? And we can release the current major version that is currently being worked on, but it will probably be like 3 months, and then this new version will be available. And it's kind of sad to move people over to a new API, and then just a short uh, while after, they have to move over again. So I feel more comfortable leaving people that need to deliver on i11 to use a current version of Cerebral. And then when people move over to a new major version, it will be the major version that Cerebral really should be. Okay, so that's my thoughts. Please, if you manage to stay this long, please give feedback. And I hope this made some sense. Thank you.